We now discuss the solution of a problem from the section three-dimensional geometry, and the question is on the shortest distance between two given skew lines. This problem has appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The problem is, if the shortest distance between the lines x minus 1 by 2 is equal to y minus 2 by 3 is equal to z minus 3 by lambda, and x minus 2 by 1 is equal to y minus 4 by 4 is equal to z minus 5 by 5 is 1 by square root of 3. Then the sum of all possible values of lambda is, we are given four options. Option A 16, option B 6, option C 12, option D 15. That is the given problem to us. We now discuss the solution of the problem in detail. The given skew lines in vector notation are r is equal to, the vector r is equal to vector A plus mu1 times B, where mu1 is a scalar, and r is equal to vector C plus mu2 D, where A is the vector I plus 2j plus 3k, and the vector B is 2i plus 3j plus lambda k, and vector C 2i plus 4j plus 5k, vector D I plus 4j plus 5k. Agreed. And the shortest distance between two skew lines is given by r is equal to a plus mu1b and r is equal to c plus mu2d is SD, shortest distance, is equal to mod of c minus a dot b cross d by modulus of b cross d. So that is the formula what we have, and we have b, we have d. B cross d is the determinant whose first row is I, j, k, and the second row are the components of B. The components of B are 2, 3, lambda. D. The third row is the components of D, 1, 4, 5. Expanding this determinant along the first row, we get this. Simplifying, we get 15 minus 4 lambda in brackets I plus lambda minus 10 in brackets j plus 5k, and the modulus of the vector b cross d is equal to under the square root of 15 minus 4 lambda whole square plus lambda minus 10 whole square plus 5 square. And now this is expanded and simplified. We get under the square root of 17 lambda square minus 140 lambda plus 350. And C we know, A we know, C minus A, 2i minus I plus 4j minus 2j, 2j plus 5k minus 3k, 2k. And C minus A vector dot B cross D above. The B cross D above, that is I plus 2j plus 2k is C minus A dot the B cross D, the vector above, that is 15 minus 4 lambda I plus lambda minus 10j plus 5k. So take the dot product. Then take the dot product. Then simplify. We get 5 minus 2 lambda. Now we go to the shortest distance formula and substitute. And it is given by modulus of c minus a dot b cross d, that we have calculated 5 minus 2 lambda by mod of b cross d, that is under the square root of 17 lambda square minus 140 lambda plus 350. But it is given shortest distance is 1 by root 3. Now squaring and cross multiplying, we get 3 times 5 minus 2 lambda whole square is equal to 17 lambda square minus 140 lambda plus 350. Now square and multiply by 3, then we get 75 minus 60 lambda plus 12 lambda square is equal to the right hand side is as it is. Now simplifying, we get 5 lambda square minus 80 lambda plus 275 is equal to 0. Cancelling 5 throughout, we'll get lambda square minus 16 lambda plus 55 is equal to 0. The factorization is very easy. Lambda minus 5 into lambda minus 11 is equal to 0. That will give you lambda is equal to 5 comma 11. And the sum of all possible values of lambda is 5 plus 11, that is equal to 16. Let's look at our options. Our answer 16 is appearing against option A. Therefore, our answer to this question is option A. So that is the discussion of the solution of the problem in detail. And I'm sure that you have understood the solution of this problem. I wish you all the best. Thank you.